g function is defined by the area underneath f from -1 to x. Okay, so we've been given these geometric parts, so we should probably just split them up to make sure that we have the different parts. And we want to find the x coordinate of each point of inflection. Okay, so first of all, we have to find the points of inflection. The points of inflection are going to happen when the slope of the slope graph changes from negative to positive or vice versa. Okay, so that's one point. Okay, so inflection happens at x equals -3. There's going to be an inflection here as well because the slope changes from positive to negative. Okay, so x equals 0. Okay, so we want to find the x coordinate of both those points. So that means then when we want the g of 0, let's start with g of -3. Okay, and that's going to be equal to the position starting at -1, going backwards to -3, the area underneath that function. So remember that we're going backwards here. So the areas above and below are backwards. So we're going to have this area here is going to be -0.5. This area here is going to be +1. This is a quarter of a circle. Okay, the circle is 4 pi, so this is going to be negative, but it's underneath, going backwards, so it's going to be positive area. So the value of -3 is going to be -0.5 plus 1 plus pi. Okay, so the g of -3 works out to be pi plus 0.5. We're also going to work out the value of g of 0, but now g of 0 is going to be going in the positive direction. So when we look at 0 from 1 to 0, I'm going to do this in a different color, green. This area in here, this trapezoid area, is above, so it's positive. Okay, that trapezoid area, we're going to work out to be 1.5. Yeah, that's definitely 1.5. So then when we work out this value, we're going to end up g of 0 equals 1.5. Okay, so there it is. This question is from AP Exam 2016, and it's, again, fundamental theorem of calculus, where h is defined by this function. It is the area underneath the sine squared graph, and it asks which of the following equation is an equation for the tangent line of the graph at that point. Okay, so the tangent line means we need h prime of x. Okay, which means we differentiate. We're going to differentiate that integral expression, which then allows us, although we cannot integrate sine squared, we can say that the derivative of this expression is equal to sine squared of x. Okay, so there's our h prime expression. Okay, we can just use the fact that the derivative and integral cancel each other out or undo each other, and then we want to know what the equation of the tangent line is. So we want to find the slope at pi over 4. Okay, so pi over 4 is going to give us square root 1 over root 2, and squaring that. That's my slope. I need my coordinate at y position at x equals pi over 4. Well, if I want to find out that, it looks like this. So h of pi over 4 is equal to the starting point is going to be 0, isn't it? So we know that it's going to be pi over 4 to pi over 4 of sine squared t dt. That area is 0, so we know that when x equals pi over 4, y equals 0. Okay, so then my equation of the tangent line, I've got my slope got my points. Y equals 1/2 x minus pi over 4 plus 0. So it looks like, yeah, answer is D.